Today we're going to write numbers and perform operations in scientific notation. So when we're doing this, you're going to attend to precision when you convert between standard form and scientific notation, and you will also look for and express regularity in repeated reasoning. So you're going to see patterns, you're going to see structure when performing operations in scientific notation. So to get started, I'm going to show you an example of standard form. So that's any number that you're used to seeing. It can be 2041. It can be 0.00362, or it can be something as simple as 1. It's any normal number that we are used to. An example of a number in scientific notation would be 3.44 times 10 to the 7th. Or it could be something like 3.44 times 10 to the negative 7th. But they both have that same structure. They're both going to have a number times 10 to an exponent. So the number in front, the coefficient, will change and the exponent will change, but it'll always be multiplied to a power of 10. So let's first look at this coefficient, the number being multiplied out front. That number always has to lie between 1 and 10. Okay, that's a rule of scientific notation. If it's not between 1 and 10, then that number is not in scientific notation form. The exponent in scientific notation represents how many decimal. So why do we use scientific notation? Why do we write it in this complicated way instead of just writing out the numbers in standard form? Well, especially in science, which is why it's called scientific notation, there's really big numbers and there's really, really small numbers. Well, you don't want to have to write those numbers out every time. I'm talking something like 4 trillion. Yeah, 4 trillion. Okay, if I had a number like that, I wouldn't want to rewrite that over and over again. So they came up with this scientific notation to be able to make it easier to write really big numbers and really small numbers more easily. So scientific notation is in the power of 10. So you are always multiplying by a power of 10. So to get us into this mindset, let's go ahead and fill out this pattern. Okay, if you need a little bit more help thinking about what these equal, think back to the beanstalk, the second half of the plant activity that we did, when you had 10 as your base and you were raising it to a power. Okay, 10 to the first is 10, 10 to the second is 100, 10 to the third is 1,000, 10 to the fourth is 10,000. The number of zeros is just what the exponent is. The exponent's 4, so this number has 4 zeros. Okay, 10 to the 0 is 1. So remember, any number to the power of 0 always equals 1. 10 to the negative first is 1 over 10, which if I write that as a decimal, that is 0.1. 10 to the second is 1 over 100, which equals 0.01. 10 to the negative third is 1 over 1,000, which equals 0.001. And then 10 to the fourth is 1 over 10,000, which equals 0.0001. Remember, a negative exponent is not a negative number. It means the inverse. This next information is really, really important. So make sure you're understanding what I'm saying here. If scientific notation has a power greater than 0, so that means it has a positive exponent. So if it has a positive exponent, then the standard number, the regular number, is going to be greater than 1. If scientific notation has a power less than 0, so if it has a negative exponent, then the number is going to be less than 1. So if it has a positive exponent, it's going to be a big whole number. If it has a negative exponent, it's going to be a small decimal. So let's go ahead and work on converting these numbers from scientific notation to standard notation. So starting with 5.8 times 10 to the 4th, I'm going to write out 5.8, and then I can move my decimal place 4 times, because 4 is my exponent. 4 is positive, so this number is going to be a large whole number that's greater than 1, which means I'm going to move my decimal place to the right to make a larger number. So I'm going to move it 1, 2, 3, 4 times. That's my new decimal point, and I'm going to fill in these little spots with zeros. So this answer is 58,000. Now, when we do these, I don't want you doing these little curly cues right here every time. All right, so let's talk about how we can figure this out without physically moving the decimal point like that. If I see my exponent is 4, I know that it's going to be moved 4 spots, and it's positive, so it's going to move to the right. Okay, so it's going to take up 3 spots to the right. So my first spot to the right of my decimal point is already taken by a number. So there's still 3 spots left after that 8 that need to be filled with zeros. So that's why there's 3 zeros. Another way you can look at that is looking to the right of this decimal point. There's 1 number in there. You can take 4, which is my exponent, minus 1, which is how many numbers are after that decimal point, and that equals 3. And I have 3 zeros. Okay, let's try this with the next one. 2.947 times 10 to the negative 3rd. So my exponent is 3, so I'm moving my decimal point 3 spaces, but this one's negative, so I'm creating a smaller number, which means I'm moving my decimal point to the left. So I'm going to look to the left of my decimal, and there's 1 number, which means that there's going to be 2 more zeros between that number and my decimal point, because 3 minus 1 is 2. So this one I can put my decimal, my 2 zeros, and then fill in the rest of my numbers. Okay, that's like if I were to move this 1, 2, 3 times, put my decimal, and fill in those zeros. That's what we did without physically making those curly cues. Let's look at one more like this. 3.107 times 10 to the 0. There's 2 different ways you can see this. You can look at the exponent and say, I'm going to move my decimal point 0 times, so the answer is just 3.107. Or you can look at this and notice 10 to the 0 is 1. So this is like saying 3.107 times 1. Any number times 1 is that number. That's the identity property of multiplication. So I know that this answer is going to be 3.107. All right, so that was converting to standard notation from scientific notation. So now let's convert from standard to scientific notation. Starting with 2,870,000. Remember that in standard or in scientific notation, you're going to have a number times 10 to an exponent. So every time you do this, you need to figure out what your coefficient is and what your exponent is. Remember that your coefficient has to be between 1 and 10. So looking at this first number here, where can I put a decimal point within these numbers to make a number that's between 1 and 10? Okay, so that point's going to be right here between the 2 and the 8. Because 2.87 is between 1 and 10. So that's my coefficient. I'm multiplying that by 10. And now I need to figure out my exponent. So my decimal point started over here. And it moved all the way over here. So I need to count and see how many spots it moved. So it moved 1, 2, 3, 4, 5, 6 spots. So I have a 6 for my exponent, and then you need to figure out if that's positive or negative. This number is larger than 1, so that means that this exponent is positive. So this is your final answer right here. Moving on to the next one. Once again, you need to look at this and figure out where your decimal point is going to go. It'll go right here between the 5 and the 4 because 5.42 is between 1 and 10. And then that's times 10 to a power. So we need to count how many spots our decimal moved. It moved 1, 2, 3, 4, 5, 6 spots. But this time, my original number is smaller than 1. It's a small decimal, which means that my exponent is negative. So this right here is my final answer. All right, one final one. This number is not in scientific notation, so we need to make it that way. The decimal is going to go right here between the 8 and the 3 to make a number that's between 1 and 10. So this is 8.3537 times 10 to a power. This decimal place only moved 1. So my exponent is 1. And my original number is greater than 1, so my exponent is positive. So this right here is my final answer. Moving on to operations with scientific notation, let's go ahead and try out some addition. So I have 6.21 times 10 to the 5th plus 4.3 times 10 to the 9th. So what I'm going to do is I'm going to convert this number into standard form, and then I'll convert this number into standard form. Then I'll add them in the directions say to write my answer in standard or in scientific notation. So I'll need to convert that answer back into scientific notation. Okay, 6.21 times 10 to the 5th. 5 is how many decimal places will move, and it's positive, so it's going to move to the right to create a larger number. I have 2 numbers already to the right of my decimal, which tells me that I'm going to have 3 zeros left over. So I'm going to have 621 with 3 zeros, makes 621,000. Okay, next I'm going to convert 4.3 times 10 to the 9th. Once again, 9 is positive, so I'll move my decimal point to the right 9 spots. I have one number already to the right of my decimal place, which means 9 minus 1 is 8, so there's going to be 8 zeros after this. So now I need to add these two numbers. So I have 621,000. And make sure when you're adding that you line up your decimal places. So I'm going to write my other number this way to make sure my numbers all line up. And then I'm just going to add. 0 plus 0 is 0. 0, 0, 1, 2, 6, 0, 0, 3, 4. So now that I have this added, I need to write this in scientific notation. My decimal will go right here to make that number between 1 and 10. So this is 4.3000621 times 10, and I moved my decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So this answer is 4.300621 times 10 to the 9th. Okay, you're going to do the same thing for subtraction, except right here in this step, you're going to subtract instead of add. Okay, let's go ahead and move on to multiplication. So I have two numbers written in scientific notation that are being multiplied here. This is just regular multiplication. So I'm going to use my commutative property, which says I can multiply numbers in any order and get the same answer. And I'm going to group up my whole numbers, and I'll group up my bases. Okay, so I'm going to write this as 2 times 6.1 and 10 squared times 10 to the 9th. So first I'm going to multiply 2 times 6.1. I don't know what that is off the top of my head, so I'm going to go to the side and write 6.1 times 2. 1 times 2 is 2. 6 times 2 is 12. I have one decimal point that I need to move over one time. So this answer is 12.2. And then I need to do 10 squared plus 10 to the 9th. I have the same base, so I can just add my exponents. 2 plus 9 is 11. So this is times 10 to the 11th. Now you might look at this and think that you're done, but if you look closer, this is not written in scientific notation. This number, the coefficient, is not between 1 and 10. So let's focus in on this and get this part written in scientific notation. So for now, don't worry about this times 10 to the 11th. So 12.2, I'm writing that in scientific notation. I want my new decimal point to be right here between the 1 and the 2. So this is 1.22 times 10, and my decimal moved one place. So I have a 1, and that's positive because 12.2 is greater than 1. So 1.22 times 10 to the first power is 12.2 written in scientific notation. And now I'm going to bring down this times 10 to the 11th. And I will multiply my 10 to the first times 10 to the 11th. So my answer becomes 1.22 times 10 to the 12th. All right, let's go ahead and move on and do some division. Division is very similar to multiplication. Just like in multiplication, you're going to multiply the two numbers and then multiply the two bases. Or divide the two numbers and divide the two bases. So first I'm going to do 1.04 divided by 2. I don't know what that is off the top of my head, so I'll come to the side and do some long division. 1.4 divided by 2. 2 goes into 1 0 times. 2 goes into 10 5 times. 5 times 2 is 10. Subtract, bring down the 4. 2 goes into 4 2 times. 2 times 2 is 4. Subtract, that has a remainder of 0. So 1.04 divided by 2 is 0.52. And then 10 to the 8th divided by 10 to the 4th. When I'm dividing numbers with the same base, I'm going to subtract the exponents. 8 minus 4 is 4. So this is 0.52 times 10 to the 4th. This is not written in scientific notation because 0.52 is not between 1 and 10. So I'm going to focus in on that and write 0.52 in scientific notation, and then I'll worry about that times 10 to the 4th. So I want my decimal point to be between the 5 and the 2. So this is 5.2 times 10, and then my decimal moved one spot, so my exponent is 1, but 0.52 is less than 1, which makes my exponent negative. So 0.52, written in scientific notation, is 5.2 times 10 to the negative first, and now I'm going to bring down that times 10 to the 4th and write my final answer. So I have 5.2 times 10, add the exponents to get 10 to the 3rd. And this right here is my final answer. Okay, the last thing we're doing is comparing scientific notation. So the number one thing you need to look for when you're comparing numbers that are written in scientific notation is the exponent. The largest exponent is always going to be the largest number. If the exponents are the same, then you can compare the coefficients. And so then the largest coefficient will be the largest number. But first you need to look at your exponent. So looking in right here at 8.74 times 10 to the 3rd and 8.74 times 10 squared. Looking at my exponents 3 and 2, 3 is larger than 2, so 8.74 times 10 to the 3rd is larger than 8.74 times 10 squared. My next one, my exponents are negative 6 and negative 4. Negative 4 is larger than negative 6. Make sure you're paying attention with your negatives and don't get that mixed up. So 3.7 times 10 to the negative 6 is less than 3.7 times 10 to the negative 4th. This next one, 3.899 times 10 to the 4th, is the exact same as 3.899 times 10 to the 4th. So those two are equal. My next one, looking at the exponents, they're both equal. So I need to look at the coefficients. 6.8 is larger than 4.151. So 4.151 times 10 to the 5th is less than 6.8 times 10 to the 5th. And finally, looking at our exponents, once again, they're the same. So I need to look at my coefficients, and 9.3375 is greater than 7.382. So 7.382 times 10 to the negative 20th is less than 9.3375 times 10 to the negative 20th. You can go ahead and get started on your homework. Be working on it and get it done for class tomorrow. Let me know if you have any questions.